so hard. So remember, the y-axis is the concentration, and here's time, right? Concentration. Wow, that's very good. And remember, we can plot a few spots. Remember, right? And then we can add a trend line like that, right? Trend line. And then we can calculate what we can calculate the instantaneous reaction rate and average reaction rate. And here you can see this plot is what? Concentration versus time. And then here, and from there, we can figure out what? We can figure out the reaction rate. Reaction rate. And then we can also figure out what? Reaction order, right? Reaction order. And then we can figure out the rate constant, K. K. And on this basis, we can get what? The rate law. Okay, the rate law is like that. The rate law is like that. As we can see here, as the reaction goes, the concentration changes. Right? As the concentration changes, the rate, the reaction rate also changes. So, and then we can use integrate rate law to make a connection between what? To make connection between concentration versus time. Concentration versus time. So here we can get the equation. We can get, we can only, measure a few concentrations, right? And from there we can generate the rate law. From rate law, we can get the correlation between concentration and time. At any time, we don't need to measure. We can calculate. See that? We can calculate. So from the for example, 4 data points, right? From data points, from this experimental data, we can get what? We can get a rate laws. From rate laws, for example, the rate equals K. Here, just put a very simple example. And then we can integrate. We can integrate. From this integration, we can figure out, we can get the what? The correlation between, from here, we can get the correlation between concentration and time. Here, the concentration and time. And depending on the reaction orders, this correlation can have different forms or equations here. For first order reaction, as we discussed before, right? For first order reaction, we can derive, so these two equations are equivalent. For first order reaction, here, for first order reaction, from here we can derive to get this equation. And this concentration 0 means the initial concentration. 0 means time 0. When time is 0, that's the initial concentration. Okay, is known, right? We can measure it. Yeah, we can measure it. So this is the initial concentration. Here's the concentration at time t. And we know the rate constant K. And once we know the time, we can figure out the concentration at any time. Right? So it's much easier for you to is more accurate than measuring the concentration here. Is more accurate, right? And then here we give one example. So this reaction is first order reaction. It's first order reaction, even though there's a coefficient 2 here. It's still first order reaction. And then, as you can see, we make a plot of the natural log of concentration of hydrogen peroxide versus time. Because this is constant. This is constant. The starting solution is known, and then it's constant. And then it's a linear correlation, and from this linear correlation, we can figure out the slope. And from the slope, we can figure out the rate constant, K. And we need to pay attention here. Here, you can see this one. This is concentration, and then the ratio is what? Has no unit, right? Or we call it unitness. There's no unit. Therefore, its natural log has no unit either. So it's pretty much like for our lab 2, remember? For lab 2, we also make a plot of, for lab 2, okay. We make a, remember, for lab 2, we will make this plot. And then, so this is also what? When we get the slope, what I mean that, so let's see. Yeah, I mean, when we measure, right, since we got this. So we should got something like this, with data point. So this lobe is or has no or, but this part has no unit. Okay, this part has no unit. Has no unit. And then you can see this part has no unit. And therefore, what's the unit for rate constant? It should be per second, right? Per second. Because per second times second, then no unit. Okay, we need to pay attention to this. So here, and then, so we also need to pay attention to the unit of the rate constant. The unit of the rate constant can also tell the order, the reaction order. Gives us some information. Okay, give us some information. And remember last time we solved here, right? We solved here. Any questions? I just kind of briefly recap. And then we move on. So the half-time of first order reaction. The half-time can